Now students, come to that the third preparation method of the phenol, and it is from the benzene sulfonic acid. So from benzene sulfonic acid. Now the headlines meaning is clear that in this preparation method we are going to prepare the phenols from the benzene sulfonic acid here. Now this reaction is carried out in three different steps here, and which are of the three steps? In that the first step is the neutralization step. Neutralization. Then second step is the fusion, and third step is the acidification. Now here I will discuss here that these three steps one by one here. Now in the first step, that the benzene sulfonic acid here is reacts with the NaOH here. Now this should be the here structural formula of the benzene sulfonic acid. As the SO3H group is the sulfonic acid group here, and it is present on the benzene here. That's why it is known as the benzene sulfonic acid. Benzene sulfonic acid here. Now this benzene sulfonic acid reacts with the NaOH, means sodium hydroxide, and actually it is in aqueous medium here. So here on the arrow I am writing here that the neutralization, as the reaction is the neutralization. Now the question arises that why the reaction is the neutralization? Because you know very well that the students that when the reaction takes place between the acid and the base to form that the salt and the water here, and the reaction is known as the neutralization reaction. Actually that neutralization reactions this state is an example here. Okay, therefore this is the neutralization reaction, and here it forms that is the benzene ring and the SO3Na, and it is known as the sodium benzene sulfonate here. This is intermediate product is the sodium benzene sulfonate. Now here the from this here that the SO3H here that the hydrogen atom and the OH gets combined here and to form the SO3Na, and the remaining one that is the H2O here. Okay, so this is the neutralization step here. Okay, then in the second step that this sodium benzene sulfonate here SO3Na, and it is the sodium benzene sulfonate. It gets react with the excess of NaOH here, means it gets fusion with the NaOH here. This reaction is carried out at 573 Kelvin temperature. Okay, and to form here that the intermediate product again, and the intermediate product is the sodium phenoxide here. Sodium phenoxide. Sodium phenoxide here. Okay, now see here from this ONA, one time ONA. Okay, to form that the sodium phenoxide here. From this here that the NaOH here that the Na, and this Na to form Na2 SO3 here. Na2 SO3. Okay, then here which part is remaining here that the one time oxygen atom here. Okay, and two hydrogen atoms are left here, and to form the H2O here. Okay, so this is the second step here, and the third step is like this here. This sodium phenoxide on acidification, sodium phenoxide on acidification means it gets react with the dilute H2SO4 to form finally our product, and product is nothing but that is the phenol. Okay, so 2 times ONA to form that 2 times OH here means it is the phenol here, and the byproduct is the here means as the here that the 2 times Na and the SO4 2 gets combined and to form Na2SO4 sodium sulfate. So this is the preparation method of the phenol from the benzene sulfuric acid. Now I will explain this reaction be fast. Okay. Now in this reaction that there are 3 steps. First is the neutralization, second is the fusion, and third is the acidification. In neutralization reaction, that what happened here, the benzene sulfonic acid gets neutralized by the aqueous NaOH and to form the sodium benzene sulfonate here. Okay. Now in the second step, that this sodium benzene sulfonate reacts with the excess of NaOH here. Okay, means it gets fusion with the NaOH, and the reaction is carried out at the 573 Kelvin temperature and to form that the sodium phenoxide. And in third and last step, that this sodium phenoxide gets acidified with the dilute H2SO4 and to get here that the phenol. Okay, so this is the most important preparation method of the phenol. In both that this reaction may ask for 3 marks, as well as in CET also the question may ask on this reaction. Okay, so after this, that the third preparation method. Now come to that the fourth preparation method of the phenol, and it is from the cumene. So our fourth preparation is the from cumene. Now this cumene is also known as isopropyl benzene. It is also known as isopropyl benzene. Whereas this isopropyl benzene or the cumene is also known as 2-phenyl propane. And actually this is a commercial method. Now why this is a commercial method? Actually in this reaction that acetone as a byproduct here. Okay, and that acetone is a very important compound, and therefore this reaction is a commercial method here. Okay, now see here that actually what is the preparation method of the phenol here. Now here this reaction is start from the cumene here. That's why first of all I will write here that the structural formula of the cumene here, and the structure is that is here on the benzene here that the carbon atom is present, and on the carbon atom here that the 2 hydrogen atoms, the 2 here that the methyl groups are present, and here that the CH group present here. Now here actually it is known as the cumene or the isopropyl benzene here. Now why it is known as the isopropyl benzene here? Because actually that the group that is present on the benzene is the CH3 CH CH3, and this CH3 CH CH3 group is the isopropyl group here. Okay, and this is the present of the benzene, therefore it is known as the isopropyl benzene. In the MCQ or in board also sometime that the question may ask that write the structure of the isopropyl benzene here, or identify the structure of the isopropyl benzene. That time this is the structure of the isopropyl benzene here. Okay, but it is commonly known as that is the cumene. Then one more name of this cumene I have written here on the board, and that is the 2-phenyl propane, and it is the IUPAC name of this structure here. Okay, now see here that how this 2-phenyl propane name came here, that here CH3 CH and CH3 here means on this benzene here that the 3 carbon atoms are present here. Okay, 1, 2 and the 3 carbon atoms are present here. So this should be the longest chain in this structure here, and the longest chain contains the 3 carbon atoms. Therefore the name of the parental chain is the propane here. And if we give number here that this should be the first carbon atom, this should be the second, and this should be the third here. Or you can give the numbers here vice versa also, means this carbon atom should be first, this should be second, and this should be the third here. Means on the second position here, that this phenyl group is present here. Okay, therefore its IUPAC name is the 2-phenyl propane. So again, that the in board as well as that the in MCQ, means in the CET or like the other objective exam, that the question may ask that what is the IUPAC name of the what is the IUPAC name of the isopropyl benzene? Isopropyl benzene. Then its answer is that the 2-phenyl propane. Okay, so in this way, this is the structural formula of the cumene. Now here this cumene gets oxidized here from the air here. Okay, means it gets reacts with the oxygen here. Now you know that the addition of oxygen is that the oxidation. Means here that the oxidation of the isopropyl benzene takes place here in alkaline medium. Means in the Na2CO3, the sodium carbonate acts as the alkali here, and this reaction is carried out in a cobalt naphthalate in alkaline medium or in Na2CO3 medium here. Okay, now here the intermediate product is formed, and this intermediate product is known as the cumene hydroperoxide here. Carbon here, this CH3 group here, this CH3 group is as it is here, and as these two oxygen atoms gets added to this oxygen atom here, to this carbon atom here. So this intermediate product is known as the cumene hydroperoxide. Cumene hydroperoxide here. Okay, and here this is the intermediate product. Now the reaction can be shown in the two steps also, but I will write here in one step here. Now this cumene hydroperoxide on acidification, it gets react with the dilute H2SO4 here. Okay, and when this reaction is on acidification to form finally here that the phenol as an important product here. So benzene and this OH to form the phenol, and the remaining product is this one, and it is the CH3, C double bond O CH3, and it is known as the acetone here. So in this way we have prepared the phenols from the cumene or the isopropyl benzene here. Now just I will explain this reaction here. What happened in this reaction here? Now when cumene or the isopropyl benzene or the 2-phenyl propane gets oxidized from the air in presence of the cobalt naphthalate in the alkaline medium to form the cumene hydroperoxide, and this cumene hydroperoxide on acidification to form finally the phenol, and the important that the byproduct obtained in this reaction, that is the acetone. Now in this reaction, this phenol and the acetone gets separated by the distillation process here. Yes, by which process here? By the distillation process. Means here that the MCQ is developed here that, and this MCQ may also ask in the CET that in the preparation method of the phenol from the cumene, the phenol and the acetone are separated by dash, and the answer is that is the distillation. Okay, so in this way that this is the fourth preparation method of the phenol, and come toward that the last one preparation method of the phenol, and actually it is the diazotization reaction. Okay, and it is from the aniline here, from aniline, and the name of the reaction is the diazotization reaction. Now see here first of all reaction. Aniline, its structural formula is the benzene ring, and on the benzene ring here that the NH2 group is present here. Now this aniline reacts with the nitrous acid HNO2 and the HCl. Actually nitrous acid means HNO2 is formed from the NaNO2 and the HCl. NaNO2 means the sodium nitrite and the HCl here. Now this reaction is carried out at 273 to 278 Kelvin temperature. Means in degree Celsius it should be carried out in the 0 to 5 degree Celsius temperature here. Okay, and in this reaction that here the intermediate compound is formed, and that intermediate compound is the benzene diazonium chloride here. Now this should be the benzene diazonium chloride here. Benzene diazonium chloride here. Now here that from this NH2 here that N, then from this NO2 N and this Cl gets combined here and to form the C6H5 N2Cl. Okay, and this is the benzene diazonium chloride here. Now here in this reaction these two hydrogen atoms, this should be the third hydrogen atom and this should be the fourth hydrogen atom, and these two oxygen atoms means here that the here 2 times H2O is formed. Okay, so 2, 3 and 4 hydrogen atoms and 2 oxygen atoms to form that 2 H2O here. So this should be the benzene diazonium chloride here. Now this reaction is shown in the 2 steps here. Now this benzene diazonium chloride here, this benzene diazonium chloride, I will write in short here BDC as a benzene diazonium chloride. Now this benzene diazonium chloride, which on acidification here, or which then reacts with the H2O water molecule, means which on acidification here, means acidification means here that the acid hydrolysis takes place here. Reaction takes place with the water, but in presence of that is the acid here. Okay, and to form finally here that the phenol as a compound here, benzene ring, and on this benzene ring here that the OH group phenol is present here. Okay, so here Cl and H gets combined here to form HCl here, and to form phenol is formed, and this evolution of the nitrogen gas takes place here. Okay, so here what is meant by the diazotization? The replacement of primary amino group from aromatic amine by the chloride here or by diazonium chloride are called diazotization reaction. Once again I would like to repeat here that the replacement of diazonium group means N2 group from which here from the aromatic primary amine means from the aniline here by the diazonium chloride here are called diazotization reaction here. Okay, actually this the definition of the diazotization is not important. The reaction is important, and how the reaction takes place here that when aniline reacts with nitrous acid or the HNO2 and HCl, the reaction is carried out in presence of the reaction is carried out at 273 to 278 Kelvin means 0 to 5 degrees Celsius to form that is the benzene diazonium chloride, and this benzene diazonium chloride on acid hydrolysis means it reacts with the water in presence of the HCl or the acid here to form that is the phenol here. Okay, so in this way here that we have discussed that all the preparation methods of the phenols here, and here that this fifth preparation method is also important here. Actually there are total 5 preparation methods of the phenols, and all these 5 preparation methods of the phenols are very important. Okay, so let us stop here.